Hello students, next we look into the transient analysis of RC circuit. The transient analysis of RC circuit is basically having resistance and a capacitance instead of an inductor. And as you can see in this circuit, we are having 2 ohm for resistance and 1/4 farads for capacitance. The method is similar to what we have done in the case of RL. That is, first we have to draw the transform circuit and then do the analysis. Now generally, as I did previously, I should have first done step input, then an impulse input, and then for a sinusoidal input. I should have generally gone by this method, but since I have already done step and impulse in the previous RL circuit section, what I will do here is I will start with the sinusoidal input here, and I will give as to the worksheet the case of step and impulse. Okay. Now, the questions that may be asked in university examinations may not ask just about the current, but it may also ask about, so here the current is I of t. It may also ask sometimes what is the voltage across the capacitor. Find the voltage across the capacitor. So Vc of t. Now, generally what we do is we find out for the case of I of t by first taking the circuit to S domain, and from that circuit we calculate I of s, and I of s we go back and calculate I of t. Now if we are getting voltage, if we have to find out voltage, remember we will first solve here. Instead of Is, we will solve Is, and then we will find out what is Vc. Vc is some Is into the impedance, whatever is the capacitance for that, whatever is the transform capacitance we take, that we will write, and then we will find out the inverse Laplace transform to find Vc of t. So these are the changes that may occur in the methodology of doing, but basically the answer will come based on what is the value we want to find out, whether we want to find out Vc of t or I of t. Right now, I will consider that I want to find both I of t and Vc of t. So, how do we do this? So, first step is we find out what is the Laplace transform of V of t. We already know cos omega t is s divided by, so let me write it, it is s divided by s square plus omega square. Here omega is equal to 1, so 1 square is 1 into 1 by 2. So this is the Laplace transform of V of t, which is basically V of s. So therefore the transformed circuit will be, the transformed circuit can be drawn as, let me draw the circuit. So this is the circuit where we put the value of R as 2 ohms, and instead of V of t we will write it as V of s. We already know the value of V of s, and this current is going to be I of s. Now what about C, the capacitance? We have already studied that the capacitance can be represented by the capacitance can be represented by 1 by Cs. If there is a initial voltage, then it's going to be different. I mean, it will be 1 by Cs, but we have to replace a voltage source also. But here, since we don't have anything, we will just write 1 by Cs. Okay, so this is going to be 1 by Cs, which is 1 by C, which is 1 by 4 into S, which actually comes out to be 4 will go on the numerator, so it is going to be 4 by S ohms. And based on that, we can even find out what is Vc of t, because the Laplace of that will become Vc of s, capital Vc of s, and that will be equal to whatever is your is that you are getting, that multiplied with 4 by s. Okay, so I'm not going to that right now. I will first try to find out what is I of s. So taking KVL, we can write V of s minus 2I of s. Why? Because it is plus minus here, then minus 4 by s I of s is equal to 0, from which I will get V of s I already know. So I of s, from this one I will get V of s, which is 1 by 2. What is V of s? S divided by s square plus 1 divided by, what was common in I of s, which is 2 plus 4 by s. Okay, which again I have to bring it into proper form if I want to take the partial fraction. So I will have to cross multiply this. So this will become 1 by 2 s divided by s square plus 1, and this will become 2s plus 4, and the denominator s will go on top, so it will become s square. Here I have to take out 2, so I divide both the sides, the numerator and denominator, by 2. I divide both numerator and denominator by 2, so I will get 1 by 2 s square by 2 divided by s square plus 1 and s plus 2. Okay, how? By dividing numerator and denominator by 2. So therefore I can say, therefore I of s is going to be equal to 1 by 4 s square divided by s square plus 1 into s plus 2. Now if I have to find out V of s, then I have to multiply I of s, which I just now got, into 4 by s. So if I am going to multiply with 4 and divided by s, I will get the answer as s divided by s square plus 1 into s plus 2. So if I take the Laplace transform of this one, I will get I of t. If I take the Laplace transform of this one, I will get V of t. So what I will do is, I will try to find out I of s. With I of s, I will try to find I of t. Okay, so let us do it. So I of s, I will write in partial fraction form as a divided by s plus 2 for the first one. Okay, and plus bs plus c divided by s square plus 1. Why? Because this is a quadratic form, so the numerator has to be bs plus c form. I am having 4 here. If I want to find out, if I don't want to make that much a big problem, so I can multiply this with 1 by 4. So no problem. In the end I will multiply it with 1 by 4. So let it right now remain this much. That means this much portion is how much? This much portion is only this much, because I have written with a 1 by 4 I have multiplied. I can take, I can avoid 1 by 4 and take this whole equation. That is also not an issue, since I don't want you to create any confusion. Let us keep it like this then. Okay, let it be. So now this is what this whole thing is. Now this whole thing is basically this whole 1 by 4. So I have not changed much. Okay, now for here, if I want to find out a, where a, so what is a? A is going to be, I have to multiply it with s plus 2 with I of s, and then get the value at s is equal to minus 2. So that will be, if I am multiplying with it, I'll get 1 by 4 s square divided by s square plus 1 at s is equal to minus 2, which will give me 1 by 4, and s square is going to be 4 divided by 4 plus 1, which is going to be 1 by 5, which is 0.2. I can write 0.2 or I can write 1 by 5. Let me use 1 by 5. Okay. Next, I have to find out the value of b and c. So cross multiplying, if I multiply these two, I will get in the denominator s plus 2 into s square plus 1, correct? I will get this as the answer. Whereas the numerator will be a s square plus a plus bs plus c into s plus 2. And this is going to be equal to what? This is going to be equal to 1 by 4 s square by s square plus 1 into s plus 2, correct? Here the denominator, this one and this are common. So what I will get is, after cross multiplying, I will get s square plus 4, because I am talking about this and this 4, that should be equal to a square plus a. Now let me multiply bs plus c with s plus 2. So I will get bs square plus 2bs plus cs plus 2c, which is basically s square terms are going to a plus b square s square plus, which all are the s terms? The s terms are 2b plus c s plus, which is a constant term, a plus 2c. Now a I have already found out is 1 by 5. Therefore, matching the coefficients, I will get a plus b should be equal to, this one should be equal to 1 by 4. Okay, a is already 1 by 5, therefore b is equal to 1 by 4 minus a, which is 1 by 5, which comes out to be 1 by 20. Okay, it comes out to be 1 by 20. Similarly, the second portion is 2b plus c is equal to 0. Therefore, c is equal to minus 2b, correct? Which comes out to be minus 2 by 20, which comes out to be minus 1 by 10. So I can write this as 0.05 and this as minus 0.1. That is based on my interest if I want to write it that way. Anyway, what I will do is I will now write it in terms of fractions only. So what is my answer? So I of s. So I of s is going to be a, which was 1 by 5 divided by s plus 2, correct? A divided by s plus 2 plus b and c. B is 1 by 20, so it is plus b is 1 by 20 s. Should not confuse that s is in the denominator, so what I will do is s by 20. I will write it as s by 20. So it is s by 20 plus c, but c is minus 1 by 10, so I will write this as minus 1 by 10 minus 1 by 10 and divided by s square plus 1, correct? Which I can now further split it. I can split it like this: 1 by 5 into 1 by s plus 2 plus 1 by 20, because this much I am going to take it separately, and this much I am going to take it separately. That is what I am going to do. So based on that, I will write So it is going to be, this is 1 by 5, okay. This is going to be 1 by 20 s divided by s square plus 1 minus 1 by 10 1 divided by s square plus 1. Why did I write it like this? Because I know that this one's Laplace inverse is going to be e raised to power minus 2t. This one's Laplace inverse is going to be cos t u of t, and this one's Laplace is going to be sin t u of t. So therefore I can write only this much, not 1 by 20 or 1 by 5, that I have not taken, that I will write at the end. So therefore taking inverse Laplace transform, I will get I of t is going to be equal to 1 by 5 e raised to power minus 2t plus 1 by 20 cos t u of t I will write separately minus 1 by 10 sin t the whole multiplied with u of t, or I can even, instead of writing u of t, I can even write that for t greater than 0. So this is how we have done for the solve for the case of sinusoidal, that means cos. Similarly, I can find out for the case of Vs also. Here instead of finding out I of s, I can go and find out for the case of V of s. No problem, it's just a similar thing you are doing. There's no issue. Okay, so that I will leave it for you to do. Similarly, I want you to find out what is going to be for the case of V of t is equal to sine. This was cos, isn't it? So I want you to find out what will be the case when sine of 6t is going to come into play. Okay, this I will give as tutorial today. And also for the second case B, I want you to find out what will happen when V of t is equal to some, let's say 3 u of t, and similarly C when V of t is equal to delta t. So I want you to find out for all these cases. These I will be giving as today's tutorial. Please do it and submit. Thank you.